The strangest objects in the universe, redefining the cosmos. Cosmic spheres filled with pure energy, encased in an extraordinary material that stretches the limits of what nature allows. These are among the strangest and most fascinating objects in the universe. But what exactly are they? What do they look like? Are they merely a theoretical concept, or could they redefine our understanding of the cosmos forever? The most extreme objects in existence are born from the violent deaths of massive stars. When a star of sufficient mass reaches the end of its life, it undergoes one of the most dramatic events in the universe, a supernova. This process occurs in less than a second. The star's core collapses under the immense force of its own gravity, while its outer layers are thrown outward in a spectacular explosion. The resulting brightness can outshine entire galaxies. Depending on its original mass, the collapsing core may take one of two conventional paths. It can become an incredibly dense neutron star, or it can collapse even further, forming a singularity, an infinitely compact point where space and time cease to function as we understand them. This leads to the formation of a black hole. However, there exists a third, even more perplexing possibility. Instead of condensing into an infinitely dense point, the collapsing core might be crushed so thoroughly that its matter is converted entirely into energy. This energy, in turn, creates a sort of miniature universe within the collapsing star. Just like our own universe, this bubble of energy strives to expand outward. But as it does, it collides with the immense mass of the imploding star. The resulting clash of forces, an unstoppable outward expansion against an immovable inward collapse, forms a new kind of material that is theoretically possible but has never been observed before. Then the process comes to a halt, and a new cosmic entity is born. Visually, these objects resemble enormous cosmic bubbles. Like black holes, they can have a wide range of masses, but a typical example might be comparable in size to a major metropolitan area while possessing the mass of 10 suns. Their outer shell is extraordinarily dark and unimaginably cold, only a fraction of a degree above absolute zero. Even when viewed in deep infrared, the surrounding cosmic background radiation appears brighter by comparison. Unlike conventional matter, the shell of this strange object is composed of an unknown, ultra-thin material, so extreme that individual atoms appear enormous in contrast. Despite its thinness, this shell is incredibly strong. To stretch it by even a single meter would require an energy output equivalent to that of a supernova. As strange as the shell is, the interior of this object is even more baffling. Unlike anything else in the universe, it contains nothing, an absolute vacuum, devoid of any atoms, particles, or waves. And yet, despite its emptiness, this vacuum is teeming with the most fundamental and primordial energy that physics can describe. To understand this, we must delve into the nature of reality itself. At the core of all matter are subatomic particles, but these particles are not solid objects. Instead, they exist as waves within a fundamental underlying medium, a kind of cosmic fluid that fills all of space, even the voids between galaxies. In most parts of the universe, this fluid exists in a relatively undisturbed state, occasionally rippling to form the particles that make up ordinary matter. However, in the interior of one of these strange objects, this vacuum fluid has been compressed to an extreme degree, concentrating an unfathomable amount of energy into an incredibly small space. The result is a region of space where the vacuum itself is pushed to its absolute physical limits, just as a black hole's singularity represents the limits of gravitational collapse. The shell of this cosmic entity acts as an impenetrable barrier, preventing the compressed energy inside from expanding outward. This creates a perfect equilibrium between two opposing extremes: the crushing force of the collapsing star and the uncontainable expansion of pure energy. The result is an object that, from the outside, is nearly indistinguishable from a black hole. Both distort spacetime to an extraordinary degree, causing light to curve around them and slowing time near their surface. Just like black holes, they can trap matter in accretion disks and produce the strange gravitational effects that have captivated scientists for decades. If someone were to fall into one of these objects, they would be torn apart by intense gravitational forces before even reaching the surface. Their atoms would likely be broken down entirely and converted into the exotic vacuum energy inside, causing the object to grow ever so slightly in mass and size. This may seem like a purely theoretical scenario, but it highlights the fascinating physics at play. For a long time, black holes themselves were considered nothing more than mathematical oddities, valid solutions to equations, but far too bizarre to exist in reality. For decades, few believed they could actually be found in the universe. Yet, continued observations revealed stars orbiting invisible behemoths, light bending around empty regions of space, and gravitational waves emitted from colossal cosmic collisions. Eventually, we even managed to capture images of the space surrounding black holes, confirming their existence beyond a doubt. Despite their elegance, black holes pose fundamental problems for physics. They seemingly erase information, contradicting key principles of quantum mechanics. They contain singularities, where our best physical theories break down entirely. The objects described here offer a potential solution. They eliminate the need for singularities, preserving information instead of destroying it. Yet, in doing so, they introduce their own mysteries: exotic matter forming the ultra-cold shell, a dense vacuum replacing the traditional concept of a singularity, and a new perspective on the fundamental structure of the universe. But are these objects real? Could they actually exist? Fortunately, there is a way to find out. One of the key differences between them and black holes lies in their structure. Black holes possess an event horizon, a boundary beyond which nothing can escape. These alternative objects, however, have a physical shell. This distinction should lead to subtle but detectable differences when they collide with one another. Such collisions generate gravitational waves, ripples in space-time that propagate at the speed of light. While the merger of two black holes produces a sharp, quick gravitational signal, the merger of these alternative objects should create lingering echoes, like the ringing of a cosmic gong. Scientists are currently searching for these faint echoes in the gravitational wave data we collect from cosmic events. However, the immense gravitational fields surrounding these objects obscure many of the signals we hope to detect. Advanced technology is required to separate these signals from the noise, and while we have made tremendous progress in recent years, we are not yet at the point where a definitive answer can be given. For now, these objects remain in the realm of speculation. They could provide answers to some of the deepest questions in physics, or they may simply be another concept that fades away with further study. Yet, this is the essence of scientific discovery, the realization that our understanding is constantly evolving, and that every answer leads to new questions. The journey to comprehend the nature of reality never truly ends. It is an ongoing process, requiring curiosity, persistence, and a willingness to challenge our assumptions about the universe.